So welcome to another tutorial for HCS Analyzer. So this time what I propose to you is to show you how to generate a synthetic screening in order to make your own test and in order also to check all the possibility of HCS Analyzer. Okay, so first of all, let's start HCS Analyzer, then go into the File menu and go directly to Generate Screen. As you can see, you have the choice between three different kind of screening. So Univariate Screening is more dedicated to generate one simple screening that is more related to HCS data. It means that we will generate a screening with only one descriptor. Multivariate Screening, on the opposite, will generate a screening with different kind of descriptor. So it will be much more, I would say, high content screening. And histogram base is something quite different that we will introduce later, that will basically generate more than one data per well. Okay, so let's start with Univariate Screen to show you all the possibility. So here it is. So this is a window where you can design your own screen. So the first thing is to design the plate and the screening by itself. So here we are dealing with 10 plate with a regular 384 well plate with 24 columns and 16 rows. So let's keep it this way for this time. After here, what you can see is you can generate three different kind of phenotype, what we call phenotype or classes. The first one is the compound phenotype, the compound classes, which is just basically a random Gaussian distribution with a mean value of 1000 here and a standard deviation of 3000. Of course, you can change it as much as you want, so let's put 200. And here, as you can see, we have also defined two control. Positive control that will be generated on column number 2 and negative control that will be generated on column number 1. So both of them have different average value and different standard deviation. It's up to you, you can change them as much as you want. So if I start to do that, let's take a look at what's happening. We are generating, as we said, compound value for 10 plate on a 384 well plate with two different classes. Let's move to the class display mode and we can see that we have on column number 2 positive control or negative control, and on column number 1 positive control. Okay, so if we move to another plate, all the plate follow exactly the same design. We have all the same control, same kind of distribution, of course different values, but they all follow the same statistical rule. Okay, so let's start again and let's generate again a univariate screen, but this time let's go to BIOS, because this software allows us also to add some kind of systematic error to the screen if we want to develop after or test application that will correct or identify systematic error or to check the robustness of our algorithm. So as you can see, here we have different kind of artifacts that we can add to this screening. Those 4 different artifacts are quite regular artifacts that people working in screening context get used to see. So we have row effect, column effect, edge effect, and ball effect. If you can check one or more, and all the effect will be combined in the end. Okay, let's make it simple for the moment, and let's just work with the edge effect. The edge effect is an artifact that is happening on the boundary of the plate, and which is basically spreading within the plate, within the center of the plate. So the shift values that you can see everywhere just give you the strength of this specific artifact compared to the others. So that's a kind of weighted value for this artifact. Here, for edge effect, you have one parameter that is the iteration. This is based on diffusion process. So basically, if you put 1, what will happen is you will have a real small but important effect on the boundary of the plate. If you start to put 2, 3, 4, 5, 6 or even 10, the effect will be spreaded within the plate. That's something that is quite interesting also to make some tests. Is, as you can see, some button, when you move on them, you can see that they turn into gray. and you can click on them. What does it mean? It means that this parameter will now vary among the 10 plate. So it will start at 1 with a step of 1. So it means that plate 1 will have an edge effect of 1, plate 2 will have an edge effect of 2, etc., etc. So let's keep it this way and let's take a look at what we generated. As you can see, on plate 0 we have a quite precise and well located border effect. But as we are moving into the plate of the screening, we can see that this effect is spreading, and if we go on number 9, this is quite important effect that's spread out within the plate. Perhaps to have a better view of this, we can go on full screen view, and here this is clear that we can see for every plate the artifact is spreading. Okay, so you can also check global normalization to have a view of this artifact using the same lookup table. Of course, the classes are all the same, but the values are quite different. So of course you can move from one plate to another by double clicking on it. Okay. We can do the same by going here, and let's just keep this way. We don't put any artifact, and here, as you can see, we can also make the standard deviation of the value changing from one plate to another. So let's click on it and let's put 1 as a starting point. So we can see that we have a step of 30, so it means that the first plate will have 1 as standard deviation, the second one 31, etc., etc. Let's take a look at what's happening among those 10 plates. So we can see that at the beginning the standard deviation is quite low, so all the values are more or less the same. You can see that we are almost at 1000 something. But if, as we are moving from one plate to another, you can see that little by little the noise is coming and the values are changing. Again, we can take a look at the full screening by checking this. So this is how you can generate your univariate screening. During the next tutorial we will take a look at how we can generate multivariate screening.